All right, so we're going to talk about solving one-step equations because what we're working towards is being able to solve two-step equations. And a two-step equation is where we group our variables and our constants, and then we divide. A one-step equation is where we only either A, group our variables, or B, divide. We don't do both. And if we can't solve a one-step equation, then we're never going to be able to solve a two-step equation. So that's why we're starting with this. Some vocabulary I want to review is variable. So any letters that you see, normally it's going to be X, but it can be any letter. That's a variable. A constant is a number that doesn't have a letter with it. So 10 and 3 in this first example, and 155 are the constants in the second example. Inverse operations are the opposite of the operations. So, for example, in this 10 equals X plus 3, we have plus 3, and the inverse of that is minus 3. In the second example, we have 100 minus X. So the opposite of 100 is minus 100. The opposite of X would be, or the opposite of negative X would be plus X. We're doing the opposite of whatever sign is in front. Coefficient is if there is a number in front of the variable, and in these two first examples, there's no number in front of the variable, so except for this one, which we'll talk about when we get to it. We don't see one though. So what a one-step equation is it's always asking the same question. One step, two step, it doesn't matter. It's always asking the same question. And that question is, what value can we substitute for X that would make this statement true? So if we're looking at the first example here, 10 equals X plus 3, we're asking, what can I substitute for X that would make this true? So in other words, we're saying, what number plus 3 is equal to 10? So this is something we can do in our heads, really, if we think about it, because we all know that 3 plus 7 equals 10. But if we were working with like bigger numbers and it wasn't so obvious, then there's an easy way we can figure that out. So we know that 10 is the same as 7 plus 3. We also know that 10 minus 3 is equal to 7, and 10 minus 7 is equal to 3. These are all facts that we've learned before. So that's essentially what we're doing whenever we're solving an equation, is we're just applying the same logic. And the way we do that here is we have to use our inverse operations. So we want to group up our constants, 3 and 10, and get X by itself so that we can figure out what X is equal to. So I would use my inverse operation. The opposite of plus 3 is minus 3. And if I do it on the left side of the equals sign, I have to do it on the right. And if I do it on the right, I have to do it on the left. So I'm subtracting 3 from both sides. 10 minus 3 is 7, which is equal to X. So that's how we would solve something like that. Here, this second one here is a little more complicated, but it's the same, only because the numbers are bigger, but it's really the same idea. We're saying, what can we substitute for X to make this statement true? So X minus what number is equal to 55? So if we don't know just off the top of our heads what that number would be, we would use the same kind of logic to find out. So 100 minus 55 would equal X. 100 minus X equals 55, just like 10 minus 7 equals 3, 10 minus 3 equals 7. So what if we just don't know what that number is? We're going to use inverse operations to find out. We need to get X by itself. So to do that, I need to get this 100 to the other side. This is a positive 100, and I know that because there's no minus sign in front of it. So I need to use the inverse operation. So if I'm going to subtract 100 from the left side of the equal sign, I have to subtract 100 from the right side of the equal sign too. 100 minus 100 cancels out, and I just have negative X on the left. 55 minus 100 is negative 45. And this isn't done though, because we have to solve for x, not negative x. So remember I said there was no coefficient? Well, that was kind of a lie. There is a coefficient here. This negative x is the same thing as saying negative 1 times x. There's just an invisible 1 right there. So to get that x by itself, we're going to divide both sides by negative 1. So this really is a two-step equation because we have to subtract and we have to divide. So these 1's cancel out. On the left side, I just have x. Negative 45 divided by negative 1 is just positive 45. And that's how we would solve for that.